Welcome to this explainer. Today, we're doing something really fun. We're literally tearing apart a real-world codebase to see how just one single architectural shift can totally transform it. We're diving right into part 152 of Ang's Notes on Haskell Programming. And we're going to explore this really brilliant refactoring journey that tackles a huge, universal headache for basically all of us, handling errors. Now, be honest. Have you ever been knee-deep in a codebase, desperately trying to figure out why something crashed, only to be handed a completely unpredictable, plain text string as an error message? Yeah, we've all been there. Are strings ruining your code? Because honestly, it's a massive pain point. When you just pass errors around as regular strings, you're literally throwing away your absolute biggest ally, the compiler. It can't catch them for you, it can't categorize them, and it definitely can't force you to handle them properly. You're basically flying blind, just crossing your fingers and hoping whoever wrote the function actually documented the exact text of every single possible failure. And you know, this perfectly captures exactly what the author, Ang, was dealing with in their XS2 ebook console app. Think of the original state of this application like a really messy, just totally disorganized toolbox. Errors were being handled all over the place. Sometimes a module would just throw a generic string at you. Other times specific errors were totally siloed across different modules. So you'd have unsupported format and template error, all mixed in with pandoc runtime error and ebook generation error. And then of course those random string messages just floating around alongside them. It's a mess, right? This kind of fragmentation means you have absolutely zero unified way to catch and process failures, which, as you can guess, makes the code incredibly brittle. But don't worry, the solution to this whole fragmented mess is actually remarkably elegant: AppError. Instead of just letting errors scatter to the wind, the author brings in this strongly typed, completely centralized data type. Basically, imagine taking that incredibly messy toolbox, tossing it out, and swapping it for a beautifully custom-built organizer where every single potential failure state has its own perfectly molded slot. By setting up AppError, the application instantly gets a single, unified home for literally anything that could possibly go wrong. So, practically speaking, what does this look like? Well, it builds out into this really comprehensive list of constructors right inside the new AppError type. It's super explicit, it's incredibly neat, and it covers the whole shebang. Everything from file not found and invalid UTF-8 to those previously scattered errors we talked about, like template error, pandoc runtime error, and ebook generation error. There's even an open failed constructor that's specifically designed to scoop up what used to be just vague string errors. Suddenly, every single tool has a bright, unmistakable label. You're never left guessing what kind of failure you're actually looking at. Okay, so how does this actually change the code we're writing and reading every single day? Just look at the function signature for Open Ebook. The old way, returning IO either string unit, just leaves us totally guessing. I mean, what does that string even mean? Is it a missing file? Is it a permissions issue? We have absolutely no clue unless we dig way down into the function's source code. But then look at the new signature, IO either AppError unit. Bam, that is a massive aha moment right there. We've taken this vague, infinite universe of possible text strings and completely replaced it with a tight, explicitly defined type. Now, of course, actually getting to this beautifully clean state does require a little bit of elbow grease. Actually, scratch that, it takes a fair amount of work. To make this centralized error handling a reality, the author had to go in and update the module interfaces all across the application. Any place where a function signature was just kicking back a plain string to say, hey, I failed, it had to be refactored to return our shiny new, strongly typed AppError. It's definitely a systemic update, but as we're about to see, the return on that initial investment is just absolutely enormous. And here is that exact payoff. By moving all those fragmented, random errors into one single global AppError type, Ang points out some really dramatic improvements to the codebase almost immediately. First off, a ton of redundant code is just straight up eliminated. And the existing functions, they get so much simpler because now they're all finally speaking the exact same error language. But honestly, the absolute biggest win here is maintainability. Just think about it. If this app grows, and say you need to add a brand new error type a year from now, you don't have to go hunting down the right module anymore. Nope. You just add one single new constructor to AppError, you let the compiler tell you exactly where you need to update your pattern matching, and boom, you're done. It's totally centralized and totally under control. I really want to double down on what this actually means for you, the developer dealing with this code base day in and day out. It gives you instant clarity. The second you transition from messy strings to a strongly typed centralized structure, readability just skyrockets. You don't have to waste time tracing through endless lines of logic just to guess what might go wrong. You know exactly what failures are going to pop out just by glancing at the function's type signature. The compiler basically steps up and acts as your personal guide, making absolutely sure you handle every single app error case comprehensively. It's a real game changer.
It really is a beautifully simple yet incredibly effective refactor, and it's captured perfectly in part 152 of Ang's programming log. I love how the author charmingly signed off in their 2026 notes, simply saying, "Till the next post, yours truly, Ang." It's exactly these kinds of steady, really thoughtful improvements that take a fragile, duct-tape script and turn it into a genuinely robust piece of software.
So, this brings us right back to you. Think about the projects you're working on right this minute. Are you still relying on totally random strings to communicate critical failures across your app? Is your code base just littered with fragmented error types scattered across like a dozen different files? Well, maybe it's time to ask yourself, is it time to centralize your own error structures? You really might want to take a page out of this Haskell playbook. Introduce a strongly typed unified error model and just watch your code base become infinitely more readable and honestly a whole lot more resilient.